We are looking at how to find the mean absolute deviation of a set of data today. First thing we need to know is the definition of mean absolute deviation. Mean absolute deviation is the average distance between each data value and the mean. Okay, the average distance between each data value and the mean of that set of data. So let's take a look at our set of numbers here, our first set of data, and find the mean absolute deviation of this set of data. Easiest way that I have thought or learned to do this is to make a table. Okay, so I'm going to make a 3-column table, and what you're going to need to put for your titles of each column, the first column is going to be data. The column in the middle is going to be titled mean, and the third column is going to be the difference column. Okay, it doesn't have to be anything super fancy. I'll do my best here with drawing straight lines, and there we go. Not bad. Could be worse. Okay, first thing I'm going to do is rewrite all of my data in the first column. It doesn't have to be in order. It doesn't have to be anything specific. Just rewrite your data points in this first column, and that's all for the data column. Okay, so I've rewritten all 6 of my values in that first column. It doesn't have to be in order. You can put them in order if you want, but it doesn't really matter in this case. The next thing that I need to find is the mean of this set of data. Okay, we know by now to find the mean, you add them all up, divide by however many numbers you have. So I would add 14, 12, 19, 10, 11, and 6. I'd divide that by 6, and then I would get a mean of 12. So I'm going to rewrite the mean next to every data point that I have. You don't necessarily have to do this. Some of my students like to just write 12 at the top and just draw an arrow going all the way down. That's fine. It doesn't really matter. You don't have to rewrite it. I like to, just because I like the way that it makes the table look, honestly. The difference column, this is the important column. This is really how we're gonna find the mean absolute deviation. Okay, if we remember, the mean absolute deviation is the average distance between each data value and the mean. So we have a data value, we have a mean, we need to find the distance between those two values. Okay, and that's why we are going to find the difference. We're going to subtract. Okay, always do the bigger and minus the smaller one. You don't always have to do data minus the mean value or the mean value minus the data value. It doesn't matter. Just do the bigger number minus the smaller number. So I'm going to do 14 minus 12. I'm going to get 2. I'm going to do 12 minus 12. I'm going to get 0. I'm going to keep going. 19 and 12, that would be a difference of 7. 10 and 12, that would be a difference of 2. 11 and 12, that would be a difference of 1. And then 12 and 6 would be a difference of 6. Okay, the mean absolute deviation is the mean of these differences. Okay, it's the average distance between each data value and the mean. That's what we just figured out in this difference column. So I need to take the mean of all of these differences, and that's going to be my mean absolute deviation. In this case, add them all up, divide by 6, you would get a mean absolute deviation of 3. And that basically tells us kind of the spread of the data, how tightly packed our data is. If your mean absolute deviation is very small, that means that your data is pretty tightly packed together. If your mean absolute deviation is very large, that means that your numbers are ranging very high and very low. There's not a ton of consistency in your data. So in this case, the mean absolute deviation is 3.